When people picture the most powerful tanks of the Second World War, the Sherman is rarely the first machine that comes to mind. The German Panther had thicker armor and a more powerful gun. The Tiger looked terrifying on the battlefield. The Soviet T-34 became a symbol of the Red Army's advance across Europe. And yet, by the end of the war, tens of thousands of Sherman tanks had been built, shipped across oceans, driven through deserts, mud, snow, ruined cities, and narrow European roads. They fought in North Africa, Italy, France, the Pacific, and eventually deep inside Germany itself. So how did a tank that was not the heaviest, not the best armored, and not always the most heavily armed become one of the most important armored vehicles of the entire war? The answer is that the Sherman was never really designed around one spectacular advantage. Its strength came from something much more dangerous. It combined a series of practical features that made it easy to build, easy to move, easy to repair, and surprisingly adaptable. And some of those advantages were things enemy tank crews might never notice during a battle. Today we're counting down 10 features that helped turn the M4 Sherman into one of the defining tanks of World War II. And number 1 may explain why judging tanks only by armor thickness and gun size can be deeply misleading. Number 10. A turret built for fighting. Start inside the tank. Because before armor, engines, or guns mattered, 5 men had to operate the Sherman while surrounded by noise, heat, smoke, vibration, and the constant possibility of being hit. And compared with many earlier tanks, the Sherman gave its crew something extremely valuable: a practical fighting compartment. The Sherman generally carried a crew of 5: commander, gunner, loader, driver, and assistant driver. That separation of responsibilities mattered. The commander did not normally have to load the cannon or aim it himself. Instead, he could concentrate on what a commander was actually supposed to do, observe the battlefield, communicate with other vehicles, identify threats, and make decisions. This sounds obvious today. During the early years of armored warfare, it wasn't. In poorly arranged tanks, commanders could become overloaded with several jobs at once. Every second spent operating a weapon was a second they weren't watching the battlefield. Inside a Sherman, the 3-man turret helped create a more efficient crew. The commander commanded, the gunner aimed, the loader loaded. And in the confusion of combat, that organization could mean the difference between spotting an enemy first and realizing he was there only after he fired. But a well-organized crew was only useful if it could communicate. And that brings us to feature number 9. Number 9. Radios as standard equipment. One of the Sherman's less dramatic advantages was also one of its most important: communication. American tanks were designed to operate as parts of larger formations, and radio equipment became a standard part of armored warfare. That allowed Sherman crews to warn each other about anti-tank guns, coordinate movement, report enemy positions, and work with other units. Imagine 2 tanks with identical armor and identical guns. One crew sees an enemy hidden behind a building. Without effective radio communication, the warning might never reach the tank 50 meters away. With radios, that information could travel almost immediately, and armored warfare increasingly depended on information moving almost as quickly as the tanks themselves. The Sherman wasn't simply an individual fighting machine. It was a node inside a much larger network. Tank commanders could coordinate with platoon leaders. Units could respond to changing threats. Formations could redirect themselves instead of blindly following a plan that had already become obsolete. But communication wouldn't matter much if the vehicle constantly broke down before reaching the battle, which is where the Sherman begins to show one of its biggest advantages. Number 8. Reliability. There is a reason experienced soldiers often care less about impressive specifications than civilians do. A weapon that looks incredible on paper but isn't available when you need it isn't very useful. The Sherman developed a reputation for mechanical reliability. That didn't mean Shermans never broke down. They did. Tracks failed, engines needed maintenance, transmissions could suffer damage, tanks could become stuck or wear out after long operations. But compared with some heavier and more mechanically demanding armored vehicles, Shermans were generally dependable machines, and reliability creates a hidden battlefield advantage. Suppose one army owns 100 extremely powerful tanks, but mechanical problems mean only 60 are operational. Another owns 100 less spectacular tanks, but 90 can move when the attack begins. Which force actually has more combat power? the answer becomes uncomfortable very quickly. A tank's theoretical performance matters only when the tank reaches the battlefield. Sherman crews sometimes drove long distances during rapid advances, and the ability to keep moving became especially important after the Allied breakout from Normandy in 1944, when armored formations had to exploit collapsing German positions before the enemy could establish another defensive line. Every mechanical failure could slow the advance. Every functioning tank increased the pressure, but reliability alone wasn't enough, because eventually, every machine needs repairs. And this is where the Sherman had another enormous advantage. Number 7, it was designed to be maintained. A damaged tank is not necessarily a destroyed tank. Sometimes the real question is, how quickly can you get it back? The Sherman benefited from extensive standardization, large numbers of spare parts, trained maintenance crews, and an enormous logistical system behind it. Engines could be serviced, tracks could be replaced, damaged components could be changed, and vehicles that would otherwise disappear from combat could sometimes return to service. This created a strange situation. An enemy soldier might see several Shermans knocked out during one battle and assume the unit had suffered permanent losses. But some damaged tanks could later be recovered, repaired, and returned. The United States also produced enormous quantities of replacement parts and had the transportation network necessary to move them toward the front. That matters because war doesn't stop when your machine needs maintenance. The battlefield keeps moving. A tank that can be repaired relatively quickly may fight repeatedly over the course of a campaign. And this brings us to something even more important. Because before a Sherman could be repaired in France, Italy, or North Africa, America first had to get it there. Number 6, strategic mobility. This is one of the most overlooked features of the Sherman. The United States was fighting a war thousands of miles from its factories. A tank built in America might need to travel by rail, reach a port, be loaded onto a ship, cross an ocean, be unloaded, transported again, and eventually driven into battle. That placed limits on tank design. Bigger isn't always better when everything has to pass through ports, railway systems, ships, bridges, recovery equipment, and roads. The Sherman was heavy enough to provide meaningful armor and firepower, but manageable enough for the massive transportation system required by a global war. This is where comparisons with vehicles like the Tiger can become misleading. A Tiger might be more dangerous in a direct engagement. But the Allied problem wasn't simply, can we build a tank capable of fighting a Tiger? It was, can we build thousands of tanks, transport them across oceans, supply them with fuel and ammunition, repair them overseas, and keep entire armored divisions moving? The Sherman was part of the answer. Its dimensions, weight, and mechanical design allowed it to function inside a global logistical machine. The tank didn't just have to cross a battlefield, it had to cross the world. And once it arrived, it needed another quality that doesn't look exciting in photographs. Number 5, mobility that was actually useful. The Sherman was not built simply to sit behind thick armor and exchange shots with enemy tanks. It had to move with armies. It needed acceptable road speed, manageable ground pressure, and enough automotive performance to operate across different environments. Shermans fought in terrain ranging from North African desert to European farmland and Pacific islands. No tank performs perfectly everywhere. Mud could stop vehicles. Steep terrain could challenge them. Tracks could be damaged. But the Sherman offered a useful combination of mobility and reliability. Later versions and suspension developments continued improving the design. The wide-track HVSS-equipped Shermans, for example, provided better ride characteristics and reduced ground pressure compared with earlier arrangements. And mobility affected more than just speed. A tank that moves smoothly gives its crew less fatigue. A tank that can maneuver quickly can reposition before the enemy reacts. A tank that can keep pace with an advance becomes available where it is needed instead of being abandoned somewhere behind the column. Still, moving toward the enemy means eventually getting shot at. And this is where the Sherman story becomes much more controversial. Number 4, constant improvements in crew survivability. Few aspects of the Sherman have produced more arguments than its reputation for catching fire. Early wartime experiences created frightening stories about Sherman crews facing catastrophic fires after penetration. But the design did not remain frozen. American engineers studied combat experience and introduced changes. One of the most important was improved ammunition storage, including the famous wet ammunition stowage used on later Shermans. The idea was straightforward. A tank contains large quantities of ammunition. If enemy fire penetrates the armor and ignites those rounds, the result can be catastrophic. By relocating and protecting ammunition storage, designers attempted to reduce the chance of ammunition fires following penetration. The wet stowage system surrounded ammunition containers with a liquid mixture intended to reduce the risk of ignition. It wasn't magical protection. A Sherman could still burn. A direct hit could still kill or wound the crew. But combat design isn't about achieving invulnerability. It's about increasing the probability of survival. Other changes also appeared as crews adapted vehicles in the field and factories incorporated lessons from combat. And this reveals something fundamental about the Sherman. It wasn't one unchanging tank. It was a platform constantly being modified. Which brings us to number 3. Number 3, the Sherman could become almost anything. This may be the most visually interesting feature of the entire vehicle. The Sherman chassis was extraordinarily adaptable. Need a tank with a more powerful anti-tank gun? Variants appeared with the 76mm gun. Need heavier firepower against fortified positions? The 105mm howitzer Sherman could provide close support. Need to destroy enemy armor with a British 17-pounder? The British created the Sherman Firefly. Need to clear mines? Specialized equipment could be mounted. Need to cross difficult terrain, support amphibious landings, recover damaged vehicles, or perform engineering tasks? The basic Sherman platform became the foundation for a remarkable variety of specialized machines. Perhaps the strangest examples appeared before D-Day. Allied engineers developed specialized armored vehicles for attacking heavily defended beaches. Some carried devices intended to clear mines. Others could assist engineering operations. Several Sherman-based concepts demonstrated just how flexible the platform had become. And flexibility matters enormously during a long war. Because the enemy changes, tactics change, weapons improve. A tank that cannot evolve becomes obsolete. The Sherman could be modified instead of completely replaced. And one modification in particular helped answer growing concerns about German armor. The 76mm gun offered better anti-armor performance than the earlier 75mm weapon. The British Firefly went further, mounting the powerful 17-pounder anti-tank gun. Suddenly, the familiar Sherman platform could carry weapons capable of threatening some of Germany's most dangerous tanks. But this adaptability would have been impossible without another feature. A feature that had nothing to do with what happened on the battlefield. Number 2, mass production and standardization. By this point, you may have noticed something. Many of the Sherman's greatest strengths were not about winning a one-on-one tank duel. They were about winning a war. American industry produced Shermans on an enormous scale. Multiple factories participated in production. Parts and systems were standardized where possible. Manufacturing methods allowed vehicles to leave assembly lines in numbers Germany struggled to match with its heavier and more complicated machines. More than 49,000 M4 Shermans of different variants were eventually produced. Think about what that means. Not 49,000 individual pieces of equipment sitting in warehouses. 49,000 complex armored vehicles requiring engines, transmissions, armor plate, guns, radios, optical equipment, tracks, ammunition, spare parts, trained crews, fuel, transportation, and maintenance. That industrial achievement created battlefield consequences. A lost tank could be replaced, new units could be equipped, Allied nations could receive Shermans through Lend-Lease, production could continue while new versions were introduced. And because huge numbers existed, the entire support system around the tank became larger as well. More mechanics knew the vehicle, more spare parts existed, more crews trained on similar equipment, more recovery units had experience dealing with it. This produced what we might call a network effect. The Sherman became valuable partly because there were so many Shermans, and yet mass production is still not number one. Because production alone doesn't explain why the design remained relevant from North Africa to the final campaigns of 1945. For that, we need to look at the feature that connected almost everything else. Number 1, balance. The Sherman wasn't designed to dominate every category, and that may have been its greatest strength. It had adequate armor, adequate firepower, good mobility, strong reliability, useful crew ergonomics, effective communications, excellent logistical support, high production potential, and enormous adaptability. None of these alone made the Sherman extraordinary. Together, they created a tank that could actually be used at enormous scale. That's the part that is often lost when World War II tanks are compared using simple charts. Take armor thickness, put a Sherman beside a Tiger, Tiger wins. Compare gun penetration. Again, depending on the Sherman variant and engagement conditions, the German heavy tank might appear overwhelmingly superior. But now ask different questions. How much fuel does the tank require? How difficult is it to transport? How often does it need maintenance? How quickly can damaged components be replaced? How many can factories build? How easily can crews be trained? Can bridges support it? Can recovery vehicles move it? Can ships carry enough of them across an ocean? Can the design accept new weapons? Can you keep thousands operational simultaneously? Suddenly, the comparison becomes much more complicated. And this is why the Sherman shouldn't simply be remembered as the tank that sometimes had to fight Panthers and Tigers. Most tank operations did not consist of clean one-on-one duels between perfectly positioned vehicles. Shermans supported infantry. They attacked defensive positions. They fired on buildings. They fought anti-tank guns. They exploited breakthroughs. They escorted advancing forces. They carried out reconnaissance and support missions. And yes, sometimes they fought German tanks. In those situations, tactics, terrain, training, visibility, numbers, artillery, air power, mechanical condition, ammunition, and simple luck could matter just as much as specifications. The Sherman was a product of that broader reality. It wasn't built to win a beauty contest. It wasn't built to produce the most impressive armor statistics. It was built to participate in an industrial, logistical global war. And that's why the Sherman could be found almost everywhere the Western Allies fought. From the desert battles of North Africa, to the mountains and towns of Italy, to the hedgerows of Normandy, through France and Belgium, and eventually into Germany itself. The tank changed as the war changed. Guns improved, armor arrangements evolved, suspensions changed, specialized variants appeared, crews learned what worked and what didn't. And the same basic platform continued moving forward. That's perhaps the most important lesson of the Sherman. The best weapon is not necessarily the weapon with the most impressive single feature. Sometimes the most dangerous weapon is the one that does almost everything well enough, can be built in enormous numbers, can travel wherever the war goes, can be repaired when it breaks, and can be modified when the enemy changes. The Sherman had weaknesses. Its early 75mm gun increasingly struggled against the frontal armor of some later German tanks. Its armor could be penetrated by powerful German anti-tank weapons, and no amount of reliability could make its crew feel comfortable when facing a hidden Panther or an 88mm gun. But those weaknesses tell only half the story, because the Sherman did something far more important than winning theoretical comparisons. It showed OPA again and again and again, in enormous numbers, with ammunition, with fuel, with replacement parts, with trained crews, and with an industrial system capable of sending another tank forward when one was lost. That may not sound as dramatic as the thick frontal armor of a Panther or the enormous gun of a Tiger, but wars are not fought on specification sheets. They are fought by armies that have to keep moving every single day. And in that kind of war, the M4 Sherman was exactly the kind of machine the Allies needed.